Welcome to another exciting educational video brought to you by Vision Concepts Academy. So today we'll be looking at IGCSE Maths and simultaneous equation involving one linear and one quadratic equation. So in this lesson, you recognize when a pair of equations includes one linear and one quadratic equation. Solve such pairs algebraically and graphically. Then you'll be able to interpret the number of solutions, no intersection, or where we have one intersection or two intersections, and apply these skills to real life and exam style word problems. So sit tight as we move on to this video. Please subscribe to our channel. Kindly subscribe to Vision Concepts Academy for more exciting videos on the STEMs. So we'll move on to this topic, simultaneous equation involving one linear and one quadratic equation. So a linear equation is an expression that has the highest variable of the power to be 1. Example of a linear equation is 2x plus 1. Okay, so equals to 0 or equals to any other number, constant. So the variable in this equation is x, and the highest power of that variable is 1. So 1 is somewhere here. But for quadratic equation, the highest power of the variable is 2. So example of a quadratic equation, okay, so this is linear. So quadratic equation includes y, yes, y is equals to x squared plus 3x minus 1. So this is a quadratic equation, quadratic. Okay, so why? Because the highest power of the variable x is 2. So the highest power of the highest exponent is 2. So you have 1 as well here, but 2 is the highest power. So this is a quadratic equation, while this is a linear equation. So in this topic, we're going to be identifying these kinds of equations and solving them together so that you will get your answers in sets of 2's. So you get x1, y1 in one set, and you get x2, y2 in another set. Okay, so we're going to get one example on the board. So if, for instance, we're asked to solve these two equations simultaneously, where the first one is a linear equation and the second one is quadratic equation, the solutions are the point where the two lines intersect. So agree with me that this is a linear equation and it's a straight line graph like this, while it's a quadratic equation that will have the graph parabolic like this. So this is positive U-shape because the coefficient of s squared is a positive. So that's why the parabola is like this. So sometimes the two lines, the two equations can intersect like this. This is quadratic and this is the linear. So the point where you have intersection, the coordinates of those points are the solutions of that equation. The coordinates of those points are the solution of that equation. So you can have that solution like that, or you can have it that maybe one side cuts the graph. Okay, let me put it like this. You have one point where the line and the curve meet, or sometimes they don't meet. Okay, so but for this one, we're going to quickly solve to using algebraic methods, not graphical methods, algebraic methods to get the solutions of x and y. So to solve this algebraically, the first thing I have to do is to express both equations in terms of y or x. So that's what we're going to do. So this is equation 1, for instance. So I would say substitute 1 into 2. Substitute equation 1 in equation 2. So this is equation 1 here. Y is defined as x plus 2. So I come to equation 2. Wherever I see y, I put this here. So I come here, I say x plus 2 is equals to x squared plus x minus 2. So this is the new form of that equation. So I'm going to collect like terms. I'll collect like terms. Okay, so everything this side will go to this side. So if this x goes over, and 2 goes over, 0 will be remaining here. So I will write this again, putting the new variable that is crossing to this side in this expression, this side of the expression. So I have x squared, then this is plus x and minus 2. Now when this x plus x cross to the other side, it becomes minus x, and when plus 2 cross to the other side, it becomes minus 2. So I can solve this, I can group this to be x squared, x minus x will give me 0, so that is 0, and minus 2 will give me minus 4. So I have this is equals to 0, or I can say x squared minus 4 is equals to 0. So this is a quadratic equation, but at the same time, I can write it as difference of 2 squared, because 4 can be written as 2 squared. So I will say x squared minus, instead of writing this 4, I will say 2 raised to the power 2, which is equals to 0, because 2 raised to the power 2 is still 4. Understand? All right, so now this is difference of 2 squared, so I can group it like this: x minus 2 and x plus 2, all equals to 0. So if you have a form like this where two factors are multiplying to give 0, either one of them is 0 or the other is 0. Either the first one is 0 or the other is 0. When you have two factors, two numbers multiplying themselves, if I say a times b is equals to 0, either a is 0 or b is 0. So I'm going to apply that principle here. So I'm going to say either x minus 2 is equals to 0 or x plus 2 is equals to 0. For the first case, x is equals to, or x minus 2 is equals to 0. For this case, x is equals to, when minus 2 crosses the other side, it becomes 2. Okay, so for the second case, x plus 2 is equals to 0. When plus 2 crosses the other side, it equals to be minus 2. So there are two values for x. Either x is 2 or minus 2. Now, this is not the full solution, because I will also have to get y. It is a simultaneous equation. So I'm going to be solving for those two variables, x and y. So I will now come to this side. I will now put the corresponding value of x for these two situations, where x is equal to 2 or x is equal to minus 2, in any of the equations. So of course, I will just choose the simplest one. I will just choose for the first one. So I'll say substitute x is equals to 2 or x is equals to minus 2 in, or and correspondingly and in equation 1. Why am I doing this? I want to get y. So y is equals to, so for the first instance, okay, I will say, therefore, when x is 2, y is equals to 2 plus 2, which is 4. And when x is minus 2, so I'll put it same here, y is equals to minus 2 plus 2, which is equals to 0. So I have two solutions here. So I have, when x is equals to 2, when x is equals to 2, y is equals to 4, and when x is equals to minus 2, y is equals to 0. So this can be written in this form, in the coordinate form. I can put it here, 2 and 4, and minus 2 and 0. See, this is coordinate form. The order is x, y, x, y. So this value of x for the first one is 2. The value of corresponding y is 4. The value of x for the second time is minus 2. And the value of the corresponding y is 0. So this is how the solution is expressed. So I'm asked to solve this equation simultaneously. Y is equals to 2x plus 1, and y is equals to x squared plus x plus 3. Now the first one is a linear equation. Why? Because the highest power of the variable is 1, or the highest exponent of the variable is 1. While the second one is a quadratic equation, because the highest power of the variable the highest exponent of the variable is 2. Okay, so again, we can just take this as equation 1 and equation 2, equate them because you have y common here. I can equate them. So I have 2x plus 1 is equals to x squared plus x plus 3. So this is equal to this, that is, this is equal to this. All right, so I'm going to collect like terms. Let everything on this side go to this side so that I'll have 0 starting here is equals to, I write this one again, x squared plus x plus 3. That's, I've written this one here again. But this one coming to join them, 2x is coming to join. When it's crossing instead of equality, it becomes minus 2x. And when plus 1. So I can factorize by grouping or collect like terms. 0 is equals to x is standing alone, x squared. Then plus x minus x becomes minus x. And plus 3 minus 1 becomes plus 2. Okay, so this is the quadratic equation that I will solve to find out the values of x. So I'm going to try to use formula method, where in the previous video we said a, okay, that's the roots of the equation. The roots of the equation is equals to b minus b plus or minus square root of b squared minus 4ac all over 2a. So this is the formula for formula method. Okay, so I'll identify what a is. A is the coefficient of s squared. So a is equals to 1, b is equals to minus 1, and c is equals to 2. So I'm going to put them in this equation. So this is b is minus 1, so minus 1, that's minus 1, plus or minus square roots. B squared is minus 1 all square minus 4 dot a dot c all over 2 dot a. That's 2 dot a. A is 1 under here. All right, so I have actually just substituted what I have as all these variables in the formula equation. Okay, so this minus is 1 plus or minus, and square root. Square of minus 1 is 1, but this is minus 4 times 2. This is 4 times 2, 8, right? 8 all over 2. So I have 1 plus or minus, then root minus 7 over 2. So we are stuck here. Now we cannot continue further, right? Because I will not, this is what they call discriminant. If I get a minus value here, it means I'm not going to be getting a real root. D is discriminant. Okay, so D is the discriminant. What is D in formula equation? D is actually this component. That is square root of b squared minus 4ac. Now, if we have D less than 0, sorry. If we have D less than 0, that means we don't have real roots. No real roots. We are looking for the root of the equation. The root of the equation is the value of x. Remember, it is from this substitution. When we equate these two equations, the linear and the quadratic, when we equate them, we will not get the roots, the x values, x1 and x2. Then we cannot find the corresponding y1 and corresponding y2. But if these roots that we are looking for, all this in this process, is not real, understand? Then there's no point. The line is not meeting. You don't have. There's no intersection. Because I define it that the equation, the solution to the equation is the point where the two lines will meet. You understand? Where the two lines, where the parabolic, which is the quadratic curve, and the linear straight line equation graph will meet. So most times it's cutting like this, but sometimes you have only one root where it is symmetrically tangential. The line is tangential to the curve. You understand? Okay, so these are the situations where you can have roots for that kind of equation. But when you now come to this particular one where the discriminant is a negative, cannot be determined, this discriminant is less than zero, then no real roots. Geometrically, the lines are entirely above the parabola, entirely above or below. Okay, so we cannot go further from there. So the answer, actually, there are no real roots. So no intersection, no real roots. That's how you stop. Then you now say no intersection, points, no real solution. No real roots. Let me put it this way. No real roots. Then no intersection, points. Okay, no real solution. So geometrically, if I'm to plot this graph, the line lies entirely above the parabola. Okay, so I have this question on the board. So to solve simultaneously, so again, this first one is a quadratic equation. I beg your pardon. Why? Because the highest power of the variable x is 2. And this one is a linear equation. Why? Because the highest power of the variable x is 1. All right, so I'm going to equate of them first. That's the first procedure. So I will say equate 1 and 2. So it is now x squared is equals to 4 minus x. Because I just removed this y, equated this to this. So this is equal to this now, right? All right, so we collect like terms, or we take every term to one side. So I leave this x squared on this side, on the left hand side. So x squared, then x coming here becomes, that's minus x coming, crossing the equality sign becomes plus x. And 4 crossing the equality sign becomes minus 4 is equals to 0. Okay, so at this point, I will just solve the equation. I will just apply the completing the square. No, let me use formula methods. Easy. I will identify a, b, and c. A here is 1 because this is the coefficient of x squared. So the coefficient of x squared is 1. B is 1, coefficient of x is 1, and c is minus 4. So I'm going to be putting them in this formula to find the roots of x, okay, minus b plus or minus, that's the formula, square root of b squared minus 4ac all over 2a. So I will just b is 1, but there's a minus in the formula. So I'll say minus 1 plus or minus. Then square roots. B here is 1 square minus 4 dot a is 1, dot c is minus 4. Okay, so this is square, please. All over, all these ones are like this, okay? All over 2a. A is 1, dot 1. All right, so here, I will just put my minus here, minus 1, plus or minus square roots of 1, because 1 square is 1. Okay, minus here and minus here will give me plus. So you see now the discriminant is going to be positive. So 4 times 4 is 16, times 1 is also 16, that's 16 here, all over 2, because 2 times 1 is 2. So 1 plus 16 is 17. So I have minus 1 here, plus or minus root 17 all over 2. Okay, so here, I'm going to solve it approximately. I'll just resolve this. The square root of 17, I will get it. Then I will resolve it. I will have two solutions. One solution will come like this with the positive sign at the middle. And second solution will be the one who have negative sign at the middle. So I will say I have either 1 minus 1 plus, you see I'm using the one on top now, minus 1 plus the root 17, let me just write it down for understanding, all over 2, or again minus 1 then minus root 17 over 2. The difference between these two expressions is that this center operation is plus and this center operation is minus because there are two case scenario there. Okay, so I'll resolve this and resolve this. So I'm getting two values of x. Okay, so let me just do it here. Two values of x. So the first value of x will approximately, x will be approximately 1.56, or that's for this side. And for this side, it will be minus 2.56. Okay, so these are the two values of x. X approximately, this is approximately 1.56 or minus 2.56. So if I will now want to resolve it, to solve it for the corresponding value of y. Okay, so therefore, when x is equals to 1.56, y from this quadratic equation, this one, is equals to 1.56 all square. So I just actually put x for 1.56 for x in this expression, so I can get what y is. So this is what's happening here. So y is 2.43. Okay. So I've gotten for this one. So but now when x is minus 2.56, then y will be minus 2.56 all squared. So this will give me 6.55. So I'll write my solution like a set. This is my solution. I'll write my solution like a set. Understand? So xy, xy. X, when x is something, what is dy? When y is something, when x is something, what is dy? So the first instance, when x is 1.56, the y value is 2.43. That's the solution there. And when x is minus 2.56, the y value is 6.55. This is how you write the answer for your theory exams for the IGCSE Maths. So you write it like this. All right. So I'll just go to the graphical method. The steps you use, first of all, is to go on the graph paper. You plot the quadratic equation first. You plot the quadratic equation first, the parabola. Then on the same axis, you plot the linear. You plot the linear. So the point of intersections are the simultaneous solutions. You understand? This thing that we are actually getting now by algebraic method are actually the point where the two lines will meet. So this is, if I'm getting, let me write this one here. If I'm getting 1.56 and 2.43, then first coordinate, second coordinate is minus 2.56 and 6.55. If you plot this graph, if you plot the graph of these two equations, these coordinates, when x is 1.56, y is 2.43, that is where the first one will meet. Let's say somewhere here. Second one, somewhere here. No, this one now is minus, so it might not be like this, but I'm just trying to tell you that there are points where the two lines will meet. All right. So to plot, I will not cover plotting actually on this video. I have to make another video. If you want me to make another video concerning graphical method where you actually plot a graph, you can put it on the comment section and I would get the video out for you. But like a sneak preview, what you need to do is to get the corresponding value of x and y for each of the situation. For each of the situation, then you plot the graph of this, and you now get the intersection. So it's just easy to do. So I'm going to leave some practical questions in the comment section and our solutions. You can work towards them. Feel free to subscribe, share, so that other people can see what we are doing. I hope this video has been beneficial for you. I'd like to thank you for viewing.